This is General Mathematics Quarter 1 Module 8, the domain and range of rational functions. Okay, before we are to proceed, kindly like, share, and subscribe to my channel. Okay, let's start. So direction is read and analyze each item carefully. Encircle the letter that corresponds to your answer for each statement. Number 1 is in the coordinate system, the x-axis is called as the abscissa. Now, number 2, in the coordinate system, the y-axis is called as ordinate. Letter B. Number 3, in the linear form, y equals 2x plus 3, which is the independent variable. It's the x. In the linear form, y equals 3x minus 4, which is the dependent variable. It's the y. And in writing sets, the form x is a set of x. Set of x is an element of R such that x is not equal to 2 is called as this is a set builder notation. Okay, number 6, in a set of ordered pairs 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, the domain D are it's 1, 2, 3, 4, and 5. Okay. Next, number 7, in a set of ordered pairs 1, 3, 2, 5, 3, 7, 4, 9, 5, 11, the the y value is 5, 7, 9, 11. Number 8, some values for the domain of the rational functions f of x equals 3x squared minus 5 are 1, 2, 3, 4, and 5. Find the range corresponding to its value. So all you have to do is to substitute. To substitute x by 1, 2, 3, 4, and 5. So here is it. So we had substituted already x by 1, 2, 3, 4, 5. So when our x is 1, our f of 1 or y is negative 2. When our x is 2, our y is 7. When it is 3, that's 22. When it is 4, that's 43. And when it is 5, that's 70. Substitute. So by PEMDAS, 1 squared is 1 times 3. It's 3 minus 5 is negative 2. 2 squared 4 times 3, 12 minus 5, 7. 3 squared 9 times 3, 27 minus 5 is 22. 4 squared 16 times 3, 48 minus 5, 43. 5 squared 25 times 3, 75 minus 5 is 70. Okay, so this one is letter A. Next, number 9, some values for the range of the rational functions f of x equals 3x squared minus 5 equals 22, 70, and 295. So these are the range. Find the domain corresponding to its value. So all you have to do is to substitute f of x by these values. So this f of x will be substituted by 22, 70, and 295 and find the domain. So here is it. The first one is we substituted it by 22. So we have to transpose to the left side becomes positive 5. So this becomes 22 plus 5, that's 27. 3x squared. Then division, multiplication property of equality. So this would be divided by 3. Divided by 3, that's 9 equals x squared. Then extract the square, putting radical sign. It's equal to 3. Square root of 9 is 3. So another is 70 equals 3x squared minus 5. So transpose 5 to the right, it becomes positive 5, and it becomes 75 equals 3x squared. So divided by 3, 75 divided by 3, that's 25 equals x squared. Extract the square by putting radical sign. That becomes square root of 25, that's 5. 295 equals 3x squared minus 5. Transpose, that will be equal to 295 plus 5, that's 300. 300 divided by 3, that's 100 x squared. So extract the square root of 100, the answer is 10. So therefore the answer is 3, 5, and 10. Okay, so 3, 5, and 10. 3, 5, and 10. Okay, next. Number 10. Find the domain and range of the linear function f of x equals 2x plus 4. So when we speak of linear function, its domain is a set of real numbers, and its range is also a set of real numbers. So it's letter B. Okay, find the domain and range of the quadratic function f of x equals x squared plus 3x plus 4. So this is quadratic function. All you have to do is to find out A, B, and C. So f of x equals x squared plus 3x plus 4. Its a is 1, b is 3, c is 4, the constant. So this is the numerical coefficient of the linear term, and this is the numerical coefficient of the quadratic term. Now, a is equal to 1 and it's positive, so means the function has minimum value and the graph opens upward. So therefore, if we are going to get the coordinate or the ordinate of its vertex, it's letter k. So k is equal to 4ac minus b squared over 4a. So k, substitute a by 1, then c by 3, up by 4, then b by 3. So that becomes 4 times 1, that's 4 times 4, 16 minus 9. 16 minus 9 is 7. Divided by 4 minus 1, that's 7 over 4. So therefore, the minimum value of the function is 7 over 4 because it opens upward. So therefore, our domain is a set of real numbers, but our range is a set of y such that y is greater than or equal to 7 over 4. Is there any answer? None. Okay. Find the domain and range of the rational functions f of x equals 22 plus x over 25 plus x. Okay. Now, to get the domain, you have to equate the denominator into 0, 25 plus x equal to 0 to get the vertical asymptote. So when we equate 22 plus x equals 0, we are actually getting the x-intercept. And when we equate the denominator into 0, we actually get the vertical asymptote, that's negative 25. And to get our horizontal asymptote, so we could get, there is a horizontal asymptote of this given, it's because the degree of the numerator is 1 and the degree of the denominator is 1 and they have equal degrees. So therefore, its horizontal asymptote is the numerical coefficient of the linear term here is 1 divided by the numerical coefficient of the linear term on the denominator, which is 1. So 1 divided by 1, it's 1. Our horizontal asymptote is 1. Now, to get the domain, we will base only its vertical asymptote, so negative 25. In set builder form, it is a set of x such that x is not equal to negative 25, or in interval notation, that would be in the interval negative infinity and 25, negative 25, union, negative 25, and positive infinity. And for our range, since our horizontal asymptote is 1, therefore our y is a set of y, our range is a set of y such that y is not equal to 1. Or in interval notation, that's negative infinity and 1, union, positive 1, and positive infinity. Okay. Now, basing on the graph, if we graph this one, this is like this. Now, the graph doesn't touches the horizontal asymptote, which is 1. And the graph on the left side, when the value of x coming from the left of negative 25, the function increases infinitely. But when the value of x is coming from the right of negative 25, the graph decreases infinitely. So, to illustrate, that function of x approaches to negative infinity as x approaches to negative 25 from the right. And function of x approaches positive infinity as x approaches to negative 25 from the left. So therefore, this is the range and the domain. Next, number 13. Find the domain and range of the rational functions f of x equals x squared minus x minus 6 over x plus 2. Okay, so since, to find the domain, equate the denominator in 0, x plus 2 equals 0. So therefore, our x is equal to negative 2, our vertical asymptote. So therefore, our vertical asymptote is negative 2. So therefore, our domain is a set of x such that x should not be equal to negative 2. Or in interval notation, that is negative infinity and negative 2. And union, this is parenthesis because negative 2 is not included in the value of x. Negative 2 to positive infinity. Okay, to get the range, all you have to do is to solve. So y equals, okay, factor out this x squared minus x minus 6. That is actually x minus 3 times quantity x plus 2 over x plus 2. So cancel out x plus 2. So our remaining is y equals x minus 3. So find the value of y when our x is negative 2. So this negative 2 here is the vertical asymptote, is the restricted value of x. So when our x is negative 2, so this is negative 2 minus 3 equals y equals negative 5. So this is the restricted value of y. So therefore, our range is set of y such that y should not be equal to negative 5 or on the interval negative infinity and negative 5. So negative 5 is not included in the value of y. Union, negative 5 and positive infinity. Okay, so number 14, find the domain of the rational functions, function of x plus 3x squared minus 8x minus 3 and 2x squared plus 7x minus 4. So all we have to do is to equate the denominator into 0. So to find the vertical asymptote, equate it to 0. Then, since this is a quadratic equation, we are to factor it out. So factoring by renaming. So you multiply 2 times negative 4, that's negative 8. So therefore, negative 8, find the factor of negative 8, wherein if you are to add or combine their factors, sum up to positive 7. There are only two factors. Oh, there are only one factor. This is positive 8 times negative 1. Positive 8 times negative 1, that's negative 8. But when you combine 8 and negative 1, then is 7. So all you have to do is to bring down 2x squared, then use positive 8, that become positive 8x, rename this positive 7x into negative 1, that's negative 1x. So 8 minus 1, that's 7. Rename this linear term of our quadratic equation. Okay, minus 4 equals 0. So groupings, you group 2x squared plus 8x here, and you group also negative 1x and negative 4. You put addition on between of them equals 0. Afterwards, factoring. So what is the common factor of 2x squared plus 8x? It's 2x. So 2x squared divided by 2x is x. 8x divided by 2x is 4. And the factor of this one is negative 1. So negative 1. So negative 1x divided by negative 1, that's x. Negative 4 divided by negative 1, it's positive 4. So if you are to look at, there are two common factors of this solution. It is x plus 4. We have here x plus 4. Okay, the common factor is, the binomial factor is x plus 4. So this one divided by x, this one divided by x plus 4, the answer is 2x. And this one divided by x plus 4, the answer is negative 1. So therefore, this is the factor of our given quadratic equation. We have quantity x plus 4 times quantity 2x minus 1 equals 0. Equate this one to 0 and equate this one to 0. So x plus 4 equals 0. So our x equals negative 4. And 2x minus 1 equals 0. So transpose, that becomes positive 1. Okay, divided by 2, so our x equals 1/2. So these are our restricted values of x, negative 4 and 1/2. So therefore, our domain is a set of, is in the interval negative infinity and negative 4, union negative 4 and 1/2, union 1/2 and positive infinity. Okay, so that's our domain. Okay, next, a cell phone provider offers a new phone for 7,000 plus 1,299 monthly plan. What would be the average cost after 12 months? So all you have to do is to add 7,000 plus 1,299 times 12 divided by 12 because 12 months of payment. So this is 1,882.33 and it is close to letter B. Next, so let us have an equation y equals 3x plus 2 when x equals to 6. So find the value of y on the following equations when x equals negative 4. So all you have to do is this negative 4, you substitute it to x, substitute it to x, substitute it to x. Here, x. So what is the value? So 2y equals, substitute, Okay, negative 4, this is x, minus 6, so 2y equals negative 22. Then divided, negative 22 divided by 2, that's negative 11. Next, letter B, when this x is negative 4, substitute that 7 times negative 4 plus 4, and 3 times negative 4. This would be negative 28 plus 4, that's negative 24 over negative 12. The answer is y equals 2. Letter C, substitute this one by negative 4, and negative 4. Here is it. Then evaluate. That's 16 plus negative 4, that's 12 minus 4, that's 8. 8. But this is negative 4 plus 4 is 0, therefore the answer is undefined. Okay. Now, enrichment activity. So here, given the domain negative 2, negative 1, 0, 1, 2, determine the range for each expression. Use the table of values. Okay, so our x values are negative 2, negative 1, 0, 1, and 2. And the answer. So this is the first one, y equals 3x plus 2. When our x is negative 2, all you have to do is substitute x by negative 2. So 3 times negative 2, negative 6 plus 2 is negative 4. When it is negative 1, this value is negative 1. When it is 0, when our x is 0, 3 times 0 is 0 plus 2 is 2. When our x is 1, this would be 5 here. When our x is 2, if this is 2, 3 times 2 is 6 plus 2 is 8. Okay, x plus y equals 8. When our x is negative 2, that's negative 2, transpose, that becomes positive 2, this becomes y equals 8 plus 2, the answer is 10. And when it is negative 1, this is negative 1, transpose, that's positive 1, so 8 plus 1 is 9. And when it is 0, that equals to 8. And when this is 1, positive 1 transpose, 8 minus 1 is 7. When it is 2 transpose, that becomes 8 minus 2, that's 6. So y equals 5x minus 1. When our x is negative 2, that's negative 10. 5 times negative 2, negative 10. Minus 1 is negative 11. This is negative 1. Negative 5 minus 1 is negative 6. If this is 0, so this is negative 1. If this is 1, that's 5 minus 1 is 4. If this is 2, 10 minus 1 is 9. Now y equals 3x squared. When x equals negative 2, that's 4, that's 12. Negative 2 squared, that's 4 times 3 is 12. If this is negative 1 squared, that's 1 times 3 is 3. When it is 0, so 0 times 3, that's 0. When it is 1, that's 1 squared, that's 3. When it is 2, 2 squared is 4, times 3 is 12. So y equals 2x minus 1 equals 2. When it is x equals negative 2, that's negative 4. Negative 4 minus 1 is negative 5 over 2. Okay, 5 over 2. When x equals negative 1, that's negative 2 minus 3, that's negative 3 over 2. When our x is 0, so this will be negative 1 half. This is 0. When our x is 1, so 2 minus 1 is 1, that's 1 half. When our x is 2, that's 2, 4 minus 1, 3, divided by 2, that's 3 over 2. So x minus 2y equals 6. When your x is negative 2, that would be negative 2. So transpose, that becomes positive 2, that's 8, divided by negative 2, that's negative 4. When our x is negative 1, transpose, that's 6 plus 1 is 7, divided by negative 2, that's negative 7 over 2. When our x is 0, this is 0, therefore negative 2y equals 6, divided by negative 2, that's negative 3. When our x is 1, this is, if this is 1 transpose, that's negative 1, that's negative 1 transpose, okay, 1 transpose, that becomes negative 1, 6 minus 1 is 5, 5, and 5 divided by negative 2, that's negative 5 over 2. When our x is 2 transpose, that's minus 2, 6 minus 2 is 4, divided by negative 2, that's negative 2. So y equals x squared, quantity x squared minus 1 over x. So if this x is negative 2, that's negative 4. So negative 2, that's 4 minus 1 is 3 over negative 2, that's negative 3 over 2. When our x is negative 1, this is negative 1, This is negative 1. That's positive 1 minus 1 is 0. 0. When our x is 0, so this is 0. So this is undefined. When our x is 1, 1 minus 1 is 0. Okay, when our x is 2, 2 squared minus 1 is 2 squared. That's 4 minus 1 is 3 over 2. That's 3 over 2. So x equals y minus 3. Now, what is your value of y when your x is negative 2? So negative 2, so negative 3 transpose, that's positive 3 minus 2, it's 1. When your x is negative 1, transpose is 1, that's 3 minus 1, it's 2. When your x is 0, transpose, that's 3. When your x is 1, transpose, that's 4. Positive 3 plus 1 is 4. When your x is 2, transpose, that's y equals 5. All you have to do is to substitute the value of x by these following numbers, values of x. Okay, this number 9. Y equals x squared minus 4x minus 3. When our x is negative 2, that's negative 2. It's 4 minus negative 4 times negative 2, that's 8. 4 plus 8, that's 12. 12 minus 3 is 9. Okay, when your x is negative 1, that's 1. 1 squared, negative 1 squared, that's 1 minus negative 4 times negative 1, that's 4. 1 plus 4 is 5 minus 3 is 2. So when your x is 0, so this is 0, this is 0, it equals to negative 3. When your x is 1, it's 1. 1 minus 4, that's 3. Negative 3 minus 3, that's 6. Negative 6. When your x is 2, our y is negative 7. So here is it. When your y equals quantity x minus 1 times quantity x plus 1, when your x is negative 2, substitute negative 2 here, substitute negative 2, our y is 3. When your x is negative 1, substitute negative 1 here, substitute negative 1 here, and simplify, our y is 0. When your x is 0, here 0, our y is negative 1. And when your x is 1, our y is 0. When your x is 2, our y is 3. So these are the ordered pair. These are the set rooster method of writing set on the range values, or on the range of all of this function. Given the value of the domain negative 2, negative 1, 0, 1, 2. Okay, so independent practice now. Find the domain or range of the following rational functions. So what is the domain of this? Okay, to get the domain of this, all you have to do is to equate the denominator into 0 and find the horizontal asymptote. So here, if we equate x plus 1 equals 0, the answer is x equals negative 1. This is our vertical asymptote. And our horizontal asymptote is 0 since the degree of the numerator is 1 lesser than the degree of the denominator. So automatically, our horizontal asymptote here is 0. So horizontal asymptote. We will base our domain on the vertical asymptote, and we will base our range on the horizontal asymptote. So here, our vertical asymptote is negative 1. So therefore, in set builder form, the domain is a set of x such that x should not be equal to negative 1. Or in a set builder form, in an interval negative infinity to negative 1, union negative 1 to positive infinity. And our range values is set of y such that y should not be equal to 0. Or in an interval negative infinity and 0, union 0 and positive infinity. Okay, number 2, f of x equals 3x over x plus 3. To find its domain and range, we will equate the denominator into 0. So x plus 3 equals 0. Here is it. X plus 3 equals 0, and transpose positive 3, that becomes negative 3, and our vertical asymptote is negative 3. And to find its horizontal asymptote, so since this is, okay, the degree of the numerator is 1, and the degree of the denominator is 1, so therefore they have equal degree. So therefore, to get its horizontal asymptote, all you have to do is to divide its numerical coefficient. 3 divided by 1, our horizontal asymptote is 3. We will base our domain on the vertical asymptote, and we will base our range on the horizontal asymptote, 3. Okay, so our domain is a set of x such that x should not be equal to negative 3, or in an interval negative infinity and negative 3, union negative 3 and positive infinity. So it is parentheses because negative 3 should not be included in the value of x. In the interval notation, on the infinity part, this should be parentheses. Okay, number three is 3 minus x over x minus 7. So the degree of the numerator is the same as the degree of the denominator. They are all 1. So to get its domain, equate the denominator x minus 7 into 0. So x minus 7 equals 0, so x equals positive 7. So this is our vertical asymptote. And to get its horizontal asymptote, all you have to do is to divide the numerical coefficient of the linear term on the numerator divided by numerical coefficient of the linear term on the denominator. So here, this is negative 1 divided by positive 1. The answer is negative 1. Okay, number 3, our horizontal asymptote is negative 1. And we will base our range on this horizontal asymptote and our domain on our vertical asymptote. So our domain is a set of x such that x should not be equal to 7, or in an interval negative infinity and 7, union 7, and positive infinity. And for our range, set y such that y should not be equal to negative 1, or on the interval negative infinity and negative 1, union negative 1, and positive infinity. Number 4. Here is it, number 4. Okay, 2 plus x over x. We'll find its domain and range. So all you have to do first is to equate the denominator x into 0. So x is equal to 0, and this is our vertical asymptote. And find its horizontal asymptote. To get its horizontal asymptote, since the degree of the numerator is 1 and the denominator is 1, so therefore they have equal degrees. So to find its horizontal asymptote, all you have to do is to divide its numerical coefficient. Here 1 divided by 1, the answer is 1. So therefore our horizontal asymptote is 1. So our horizontal asymptote is the basis for our range, and our vertical asymptote is the basis for our domain. So our domain is a set of x such that x should not be equal to 0, or in the interval negative infinity and 0, and union 0 and negative and positive infinity. Our range value is a set of y such that y is not equal to 1, or on the interval negative infinity and 1, union 1 and positive infinity. Number 5. So our number 5 is f of x equals quantity x plus 1 over x squared minus 1. So the same procedure we will be doing. Equate the denominator into 0, so x squared minus 1 equals 0. Then factor out, since these two are perfect squares, so the factor is x plus 1, and quantity x minus 1 equals 0. So equate x plus 1 into 0 and equate x minus 1 into 0. So when our x plus 1 equals 0, our x equals negative 1. So this is our vertical asymptote. First, vertical asymptote, and x minus 1 equals 0, so our x is positive 1. So there are two vertical asymptotes, it is negative 1 and positive 1. Now, our horizontal asymptote is 0, since the degree of the numerator is 1 lesser than the degree of the denominator. So this is 1, and this is 2, has a degree of 2, so therefore our horizontal asymptote is 0, or the x-axis. Now, our vertical asymptote, there are two numbers, negative 1 and positive 1. So our domain is a set of x such that x should not be equal to negative 1, or x not equal to positive 1. Or on the interval from interval negative infinity and negative 1, union negative 1 and 1, union 1 and positive infinity. Our range value, we will base it on our horizontal asymptote, which is equal to 0. That's range is a set of y such that y should not be equal to 0, or again, on the interval negative infinity 0, union 0, and positive infinity. Okay, now independent assessment. Find the domain or range of the following functions using any notation. So number 1, the same procedure we did on the previous. 3 over x minus 1, equate the denominator into 0. So x minus 1 equals 0. So x equals positive 1. This is transpose vertical asymptote. And get its horizontal asymptote. Our horizontal asymptote here is 0, since the degree of the numerator is 1 lesser than the degree of the denominator. So our horizontal asymptote is 0. So we will base our domain on the vertical asymptote. So our domain is a set of x such that x should not be equal to 1, or on the interval negative infinity and 1, union 1, and positive infinity. And our horizontal asymptote is 0, and we will base our range on the horizontal asymptote. So therefore our range is a set of y such that y should not be equal to 0, or on the interval negative infinity and 0, union 0 and positive infinity. Okay, number 2, 2x over x minus 4. Equate x minus 4 into 0. So that is x equals positive 4. And this is our vertical asymptote. And get its horizontal asymptote. Since the degree of the numerator is 1 and degree of the denominator is 1. So therefore, our horizontal asymptote is 2 divided by 1. The answer is 2. So our vertical asymptote now is 4 and horizontal asymptote is 2. Okay, so our domain is a set of x's that x should not be equal to positive 4 or on the interval negative infinity and 4, union 4 and positive infinity. And our range is set of y such that range is set of a y, this is y, such that y should not be equal to positive 2 or on the interval negative infinity and 2, union 2 and positive infinity. This should be y. This should be y. Number 3, f of x equals x plus 3 over 5x minus 5. Equate the denominator into 0. 5x minus 5 equals 0. So 5x equals 5 transpose. So x equals 1 because divided by 5, the answer is 1. So our vertical asymptote is 1. And our horizontal asymptote, number 3, okay, so since the numerator has and denominator has equal degree, it's all 1, therefore its horizontal asymptote is 1 divided by 5, that's 1/5. Okay, so our domain is a set of x such that x should not be equal to 1 or on the interval negative infinity and 1, union 1 and positive infinity. And our range is a set of y such that y should not be equal to 1/5 or on the interval negative infinity and 1/5, union 1/5 and positive infinity. Okay, number 4, f of x equals 2 plus x over 2x. So equate 2x into 0. 2x equals 0. So divide by 2, divide by 2. So x equal to 0. Our vertical asymptote. Okay, or the y-axis. And to get this horizontal asymptote, since number 4, you have equal degree still. So 1 here, numerical coefficient of x divided by 2, that's 1/2. So domain is a set of x such that x should not be equal to 0 or on the interval negative infinity and 0, union 0 and positive infinity. And our range is based on our horizontal asymptote 1/2. So y is set of y such that y should not be equal to 1/2 or negative infinity and 1/2, union 1/2 and positive infinity. Okay, so number 5, f of x equals x squared plus 4x plus 3 over x squared minus 9. Now, we have the same degree still. Okay, x squared minus 9, the denominator equated to 0 since this is a perfect square. Difference of squares. So this is, the factor is x minus 3, quantity x minus 3 times quantity x plus 3 equals 0. Equate x minus 3 to 0 and equate x plus 3 into 0. So x minus 3 equals 0 and x plus 3 equals 0. So our x is 3 and x equals negative 3. These are our vertical asymptote. And our horizontal asymptote is numerical coefficient of x squared, 1. Numerical coefficient of x squared here is 1. So 1 divided by 1 is 1. Okay. So our domain is a set of x such that x should not be equal to 3 or x should not be equal to negative 3 or on the interval negative infinity and negative 3, union negative 3 and positive 3, union positive 3 and positive infinity. And our range is a set of y such that y should not be equal to 1 in set builder form or on the interval negative infinity and 1, union 1 and positive infinity.